welcome back. So in this note, we're continuing our conversation on composition functions. However, if you notice, this time there's a difference. So this time, notice I'm not evaluating for a number. I'm evaluating for x. So in this case, I'm legitimately plugging in the entire function into the other function. I'm no longer finding numbers. I'm plugging in the functions themselves. So here, you always start with your inner function. All right, so my inner function is g of x. So that 2x plus 3. I start with that inner function, and I plug it in wherever I see an x in the outer function. So this time I'm not dealing with numbers, I'm dealing with the function as a whole. So I'm plugging in that 2x plus 3. I'm plugging that in to the outer function, into the f of x function. And now I just have to simplify and combine like terms. So here notice 3 minus 5. 3 minus 5 is a negative 2. And now that I've combined my like terms, that's actually my answer. Because again, I'm not evaluating for a number. I'm plugging a whole function in for another function. So it's going to be a function in the end. All right, well, let's look at the other direction. So in the other direction, I'm starting with f of x. So I'm starting with f of x, and I'm plugging it into g. Okay, so notice this time it's a little bit different. So I'm taking f and I'm plugging it in. Oh, I'm sorry. I'm plugging f into g, where the x was. So again, taking that whole inner function, plugging it into the outer function. Well, now, to simplify this, I can distribute and then combine my like terms. And again, when you're just dealing with x in there, you're not evaluating for a number, well, what you're going to get out is still going to be a polynomial, still going to be a function. So again, the whole basis of this one is you're plugging a whole function into another function. All right, so let's dive into two other examples. So here I'm starting with g of x. So I'm starting with g, and I'm plugging it in everywhere I see x in the outer function. So I have 2x minus 1 squared plus 2. I'm taking that g of x, plugging it into wherever I see x in f of x. Well, this one is a little bit more complicated because remember, when I have something squared, that's the same thing as multiplying it by itself. So notice that if I think of it that way, now I'm going to end up having to FOIL this out. 2x times 2x is 4x squared minus 2x minus 2x plus 1. Then I still have that plus 2 at the tail end. Well, now I can combine some like terms. Negative 2x minus 2x is a minus 4x. 1 plus 2 gives me a 3. And this time that is as far as I can take it. So don't forget some of those other skills that we've picked up along the way, things like foiling and stuff like that. So let's try our last example. So again, you always start with your inner function. So with f of x, and I'm putting it in to g. You put the outer function into the inner function. So I'm going to have a 2 here, multiplying my f, which is x squared plus 2, and then a minus 1 at the end. Again, plugging a function into another function. Well, this 2 distributes, so I'm going to have 2x squareds plus 4. And I still have that minus 1 at the end. Well, I can combine my like terms and end up with that. Again, this is going to be my ending point because I have nothing else I can combine. So that's going to be the end of this process. All right, so again, getting to be a little lengthier stuff. So make sure, it's absolutely critical, you have all of this written down, and then make sure you're asking for help if there's anything that you're still confused about.